So, when we're talking about probability, let's consider a situation where I have a tree diagram, and what I'm talking about is I'm going to go to the doctor's office and I'm considering the possibility that people have the flu. Now, when we say there are people that have the flu, we want to be able to quantify that. We want to be able to put a number on it. And this is a very important concept that we want to have something called the general probability. What is the general probability? The general probability comes to us outside of our observation. Okay, so if you're going to be talking about general probability, it is not something that you personally observe. The general probability has to be given to you separately. Now, someone else might have observed it or whatever else needed to happen for this to be. But the general probability is not what you actually observe. You have to be given the general probability outside of your situation. So then, let's say that the general probability that someone has the flu is 25%. So we are told that in this particular community, 25% of the people out there have the flu. So if I were to randomly choose someone from the community, I would have a 25% chance of having the flu person. Okay? So then, what's going to happen is I'm going to go to the office, and there are going to be 6 people in the office. And I'm going to ask the question, what is the probability that all 6 have the flu? That's what I want to know. And what I'm going to do in this situation is I'm going to think about the tree diagram. And every time I choose a person, then that will create more options for me. The first person I choose will have either yes or no. They don't have the flu, or they do. Yes or no, they have. Then the second person would be another set of choices on those branches. So then the second person will also have a yes or no possibility. Then what happens when I pick a third person? I'm going to put another set of branches on those branches. So I have yes or no questions, and I have a series of them. And since they are yes or no questions, there are 2 options for every possibility. This first person, yes or no. Second person, yes or no. Third person, yes or no. So every time I'm going through this, I have to multiply in the sense of how many options I have, right? First one I have 2 options, then I have 4, then I have 8, and so on. However, what we talked about last time is that these branches do not have equal probability. For a person to have the flu is a 25% chance, or 0.25. So what's the probability that they don't have the flu? 75%, or 0.75. So if I'm going to say in this situation, all of these people have the flu, then that means I'm going to say yes. The first person, yes. The second person, yes. The third person, all 6 of them have the flu. How would I figure out that probability? Well, when I go from one branch to the next, we talked about this previously, I multiply those probabilities together. So this would be 0.25 to the 6th power. Okay? What is that? What number is that? 0.25 to 6th power. Jeff?
Got it at 0.0002.
0.0002. And there's probably more digits after that, but approximately this. So we would say, well, would I expect this? No. Okay. Not going to happen. What would then be the probability that none of 6 have the flu? How do you get that?
The complement.
Nope, that's not correct. When I say that none of them have the flu, that would be the first one says no, the second one says no, the third one says no, they all say no. In order for them to all say no, that would be 0.75 to the 6th power. What's that number?
0.178.
Approximately 0.178? Yeah. Okay. So I walk into the office and I say, would I expect this? Would I expect that none of them have the flu? What is my criterion for deciding? Jeff?
Over 95%.
Over 95%. This is not over 95%. So this is not a yes answer. It's also not a no answer because it would be less than 5%. That would be a no answer. So this would be a maybe. Would I consider it a high probability?
No.
No, it's not above 50%. So if I walk into that office and there are 6 people there and I say, what are the chances that no one here has the flu? Relatively low. All right. Now, going back to your answer here, Chelsea. The opposite of everyone is not no one. Okay? What's the opposite of no one? Or the opposite of none is actually some. If I would ask the question, is it true that no one came to class? No, that's a false statement. Why? Someone came to class. If I say, is the room empty? No. Why not? Because someone is in there. If we have this great, cold snap, let's say, and there's a business, and they say, well, I wonder, I wonder if we're going to have no customers this morning. What's the opposite of having no customers? You have someone, you don't have to have everybody come, but if you have someone, that's the opposite of no one. Well, there's a special phrase that goes with this, and that is at least one. The opposite of no one is at least one person. So that in the homework, unfortunately, when it says at least one, that's the opposite of none. So if we ask the question, what is the probability that at least one person has the flu? That's when we're going to take 1 minus 0.178. So that's the opposite. The opposite of none is some, or at least one. So if I take 1 minus 178, I'll get 822, or about an 82% chance. Will I then, if I want to interpret this, once again, what I'm looking at is I'm saying, if I walk into the doctor's office, will I expect someone to have the flu? Well, if it's at 82%, I'm not going to say for sure. This is still in the maybe category, but I'd kind of lean towards this. That's a relatively high probability. So when I walk into the doctor's office and I say, is it true that someone has the flu? Maybe so, right? If it's an 82% chance of happening, yeah, it certainly could be that. I'm not going to bet on it necessarily or assume it's going to happen, but yeah. All right, so this process then, when you look at a situation and you know a general probability, and then you ask the question, when will I have all of these things? Then it would be that general probability to the power of the number of observations. And then when you say, when will I have none of them? Then you would take the complement of the probability to that power. And then to find out at least one, you would take this number, the none, and subtract it from 1. So the formula is the probability of at least one is equal to 1 minus the probability of none. All right, so we'll consider that